Netflix has a highly interactive user interface. As I move my mouse around the page, hovering over titles and inspecting movie descriptions, there's a lot going on under the hood on that web page. One component of this UI is RxJS, a library for building reactive JavaScript. Reactive programming uses the observer pattern to create objects that emit streams of events. We can compose these different streams together to create elegant abstractions. Reactive programming may seem confusing at first, but it can simplify certain patterns that may be hard to describe with imperative programming. Ben Lesh is a senior software engineer at Netflix, and he's an advocate for reactive programming. He joins the show to explain why reactive programming is useful and how RxJS is used at Netflix. Indeed Prime flips the typical model of job search and makes it easy to apply to multiple jobs and get multiple offers. Indeed Prime simplifies your job search and helps you land that ideal software engineering position from companies like Facebook or Uber or Dropbox. Candidates get immediate exposure to top companies with just one simple application to Indeed Prime. And the companies on Prime's exclusive platform message the candidates with salary and equity up front. Indeed Prime is 100% free for candidates. There are no strings attached. Sign up now and help support Software Engineering Daily by going to Indeed.com/SEDaily. That's Indeed.com/SEDaily if you're looking for a job and want a simpler job search experience. You can also put money in your pocket by referring your friends and colleagues. Refer a software engineer into the platform and get $200 when they get contacted by a company, and $2,000 when they accept a job through Prime. You can learn more about this at Indeed.com/prime/referral. That's Indeed.com/prime/referral for the Indeed referral program. Thanks to Indeed for being a continued sponsor of Software Engineering Daily. If I ever leave the podcasting world and need to find a job once again, Indeed Prime will be my first stop. Ben Lesh is a senior software engineer at Netflix. Ben, welcome to Software Engineering Daily.
Hi, thanks, Jeff. Thanks for having me.
So today we're talking about reactive programming, reactive JavaScript. And the main library we're going to be talking about is RxJS. Could you explain what RxJS is?
Sure. RxJS is a library full of functions built around a type called Observable that basically allows you to take sets of events and operate over them, sort of like Lodash would with synchronous sets, like arrays.
Okay, and what problem is RxJS solving?
Well, it can solve a variety of problems, but the main thing it's used for is to solve kind of advanced asynchronous composition where you need to do a bunch of different things with different types of events. For example, if you're going to do drag and drop, or maybe a brush selection on a graph, or composing things coming from multiple WebSockets, or dealing with streaming data, that sort of thing.
Okay, and I think we'll dive into the drag and drop example because I think RxJS and this whole paradigm is best described by an example. You have used the example of programming this drag and drop interface before. For example, like if you're on Dropbox and you want to click and drag a file to the trash, all of this in a web interface, there are 3 sets of events that you need to listen for in that interface in order to compose them together and create this drag and drop interaction. The first thing that you talk about is that the page needs to listen for the initial mouse down on any target, and then the page needs to listen for how that mouse moves around the page, and then third, the page needs to listen for when the mouse up event happens on the document. Can you walk me through this example and what RxJS does for us? Because, explain why this way of thinking about the drag and drop interaction with these 3 different event type of observables. Why does this make sense, and what does RxJS do for us?
Sure. So really, like if you were to implement this with just imperative code and not use RxJS and do it the simplest way possible, what you'd end up with is adding a handler to, your like maybe at a higher level, like something over top of all your possible targets. But basically, you'd end up adding a handler to your target for your mouse down, and then you'd add a handler to the document for your mouse movements that would be firing all the time, and then you would also add a handler to your document for mouse ups, so you knew like if you were dragging around where you moused up, or maybe you'd add it only on your maybe you'd add it on your document and you'd add it on like a target that you were going to drop things into or whatever. Like you would have several of these events set up, and the problem is that now you've got this. Say your mouse movements where all the time you're firing this handler as your mouse is moving around the document, but the reality is that you don't really care about all of them unless you're actually dragging something. So you'd have this little bit in there that was like, don't drag this or whatever. And it gets kind of messy and it's not very efficient because you're executing code you didn't want to. So the ideal is that you would be able to set up the mouse movements and the mouse up listeners only after you had mouse down, and you'd be able to tear them down whenever you mouse up, right? So that's kind of, now you're getting into some weirder territory when you're trying to do imperative programming. And the thing about RxJS is it makes you able to do these things in a very, very terse way because it's got all of these operators that are built in. And what operators are is RxJS is built around this idea of a type called observables, in which you can take sets of events and treat them as just a set, like a set like an array, if you will, but they happen over time. So you have this series of events over time, and you can say, okay, well, for my mouse downs, I can do what's called a switch map on that. And what that does is you can map it to a series of events for your mouse movements, and you can switch to the latest from the last time you mouse down. So that's switch and map together, or switch map. And then for inside there, you can say, okay, take my mouse movements until a single mouse up. So that would be like mouse movements take until mouse up.
Right. So is the observable pattern, is it actually more efficient? Because you used an interesting choice of words. You said that if we were doing this imperatively, it would be wasteful. But when we are using observables, it is more terse. So is that to say that under the covers there is, perhaps an equal amount of waste happening and it's just easier to reason about, or is it also are there also savings when we're using this observable pattern?
Oh, well, there's savings in that with Rx, the observable can embody the setup and the teardown of any event source, which would be like subscribing to an event listener or something on a DOM element. And so you wouldn't always be listening to your mouse movements. Like that bit of waste would be gone. Now, Rx and observables, like any other abstraction, are an abstraction, and abstractions always come at a cost, whether it's a promise or an observable or whatever abstraction you put over top of something. There will be some cost there, but the cost is pretty light, especially when you're talking about things like mouse movements and things like that. It's adding a couple of additional function calls to wrap the thing that you're doing in order to have these nice sets that allow you to compose very, very tersely this behavior. I mean, it's literally a drag and drop is like one line in RxJS, where you're talking many, many lines of code that you'd have to maintain if you were to do the same thing imperatively.
So are we talking about just the main advantage that we get from them is that they abstract away this constructor or destructor pattern that we have in classical object-oriented programming, where you just have is that what we're getting here? Is that the main advantage that we're getting here? The constructor and the destructor.
So what you're looking at is the pattern that actually exists, especially on DOM elements in this add event listener, remove event listener, which I believe you're calling the constructor and destructor. That pattern is actually the gang of four observer pattern. So you have an observer, which is in the case of a DOM element, just a function, and then you have this subject, which is the actual DOM element itself. And so in the gang of four observer pattern, you have an observer that has some handler function on it, and you have this subject that has a method on it called add observer, and it's usually got another function on it called remove observer. And if you think about that in terms of add event listener and a remove event listener, it's very, very similar. And what Observable does is Observable actually takes something called an observer, or it can take multiple handlers and kind of internally scrub them into an observer that has three methods on it. The next, which is here's the next value, error if there's an error, and completion if there's completion. The reason you don't see those other two on DOM elements is because they're not really possible. They're not going to throw an error directly from the DOM element at you during event listening, right? And they're not going to complete. So you only have the one basically next handler is an add event listener. But what Observable allows you to do is it allows you to tie. It's basically a function that ties an observer to a subject. And that subject could be another observable. So that allows you to kind of chain multiple observers together functionally with these observable chains where you're mapping and switch mapping and that sort of thing to tie some end observer to some source subject, right? So the advantage is you get this kind of this domain-specific language built on top of the idea of treating events as sets of things that allows you to tie any data producer, which you would think of as your subject, to any observer, which is where you're creating some side effect from that, like whatever you do when the drop occurs or as you're dragging, that sort of thing.
Got it. So I did a show with Matthew Podvisaki a while ago about the reactive extensions and RxJS, and I heard in that conversation he was talking about the same idea where you have these streams of events that can be acted on just like arrays can be acted on. And he said multiple times, events are a collection. How true is that under the covers? Are the streams that are being published from an observable, like a mouse event, are these being published as a collection or are they being published as a stream?
Well, I mean, it's a bit of both. I mean, it's the fact that a stream is a collection of things over time. So when you think of an array, you think of it as a collection, and they're one-dimensional collections, right? They have a length. With observables, you've got a collection where it's more two-dimensional. You've got a number of items that'll come over an observable, a length that you can't really measure statically most of the time. But you also have this element of time involved, which is why you can't measure the length of it statically. So you've got it's kind of a two-dimensional collection of things. And whenever you have a collection of things, there are, there's various maths that you can apply to them. Like you can join two sets of things. You can, filter out a set of things into a new set of things. You can map a set of things into a new set of things, and so on.
Right. So when we're talking about the drag and drop, for example, once we have these observables set up, like because the first step in this process is to initialize these observables. We're observing for the mouse down event, we're observing for the mouse moving event, we're observing for the mouse up event. So you actually initialize in the code these objects, these abstractions of what we are observing, these observable things. Once we have these objects, these observables set up that are entities representing these different mouse movements, how is the function composed? Like the function that takes advantage of these different observables and stitches together some kind of action that we want to take?
Sure. So basically, what's really happening with an observable is, as I stated before, you give it this observer, which has three handlers on it. And it's going to take that observer and it's going to tie it to some data source, wherever that may be, whether it's a WebSocket or another observable or a DOM element or whatever. And but the observable itself is just a function. It's inert. It doesn't do anything until you subscribe to it, and then it sets up this chain of observers. So to go back to the gang of four observer pattern again, and the observable does not exist anywhere in the gang of four canon, right? It's not something that was created until afterwards, but really what it is It's basically taking your observer that you were going to subscribe to your subject with and adding a bridge of observers in between it, like wrapping one observer inside of another so they can transform the values that are coming out of your subject before they arrive at your observer where you're actually doing your observation. So whenever you subscribe to your observable, it's basically a function that sets up that subject observation sort of scenario. So it actually starts doing that sort of observation. And then it returns to you this subscription object that is just a cancellation semantic. So when you call unsubscribe on the subscription object or dispose in older versions of RxJS, it will basically remove your observer from the subject that it was tied to.
Got it. So now that we have talked through some of the basic ideas of reactive programming, we've talked about this example of the drag and drop. What are some ways that we can think about reactive programming more generally? Because most of us are used to simply imperative programming. This is the way that we think about code in our head. What is necessary to make that paradigm shift to think about programming reactively?
Well, reactive programming is a much broader topic than RxJS and observables. Generally speaking, you can think of reactive programming as sort of a declarative form of event-driven programming. So what you would have is there's a couple different types. There's push-based reactive programming, which is what RxJS is, where you basically you have multiple steps to what you're doing. So each step is independent and doesn't care about the previous thing that happened before it. So if it's map and filter and so on, a filter doesn't care what map did right before it, and vice versa. And what they're doing is they're reacting, if you will, to a value arriving at that step. So a value arrives at that step, it does what it needs to do, and it passes it on. And then the next step reacts to it arriving at that step, and so on. So that's push-based reactive programming. Now, pull-based is similar, but it goes the opposite direction, where you would call like a next method. So this would be like your iterator sort of example, where you say, give me the next value. And maybe you've composed a map and a filter and whatever through in a pull-based scenario. And what it would say is, give me the next value. Okay, give me it from this mapping function. And then that mapping function would say, give me the next value from what came before me, which was a filter function. But in each step, again, has no idea what step it's pulling from. It just says, oh, give me the next one from this iterator. It doesn't realize that iterator came from a filter function or came from a mapping function. So it's declarative in that each step is kind of independent and you can compose it however you want. And each step doesn't know anything about what the previous step is. So that's more reactive programming.
Right. And there seems to be a trend towards declarative programming at all layers of the stack. I feel like when I talk to the Kubernetes people, they are often talking about declarative syntax, and that is one of the advantages. What do you think is? I mean, first of all, do you agree with that? Do you feel like that's a trend that's happening, and do you have any reasoning behind why that trend is happening?
Sure. I think it's a trend I mean, you see it. Another place that you see it actually is in React. So
yeah,
a lot of fans of React are now creating React components, for better or worse. I don't know if I always agree with this approach, but they're creating components so they can use JSX to declaratively set up behaviors. And what I mean
not just UIs, you mean?
Right, not just UIs. Like I've seen one where somebody did audio processing, which was like adding effects with markup. Like markup in general, like HTML, is declarative programming. You add a button tag, and magically a button appears at whatever space that you added it. Like it doesn't care if there was a table somewhere above it in the HTML. The button tag is independent of the table, right? It's purely a declarative language, HTML. So I think when it comes to JavaScript and programming in general, the reason that you find declarative programming to be so popular is because Well, one, we're at a stage where now there's a lot more processing power to handle some of these abstractions. Like an abstraction like an observable isn't going to cost you very much. And two, it allows you to easily go in and alter code in a very, very in very striking ways without adding, without doing too much to the code around it. So, for example, let's just say I had a button click that was going to do an AJAX request. And it's like if I'm using Rx and you're just switch mapping button clicks into AJAX requests, then someone comes along and says, well, what if I don't want to spam the server? Then you just add debounce time right above it, and all of a sudden you're between the button clicks and that switch map, and all of a sudden you've got client-side rate limiting in there. And then someone else comes along and says, well, you know what? What if that, I don't want that AJAX request to last too long. I'd like it to have like a timeout behavior. And then you go in and say, okay, well, no problem. I can add a timeout operator after it inside the switch map, and now it's got a timeout behavior. And then someone else comes in and says, I don't want it to be AJAX anymore. I need you to get it from a WebSocket that just gives you a single value and closes. No problem. You just pop out the AJAX part and pop in a WebSocket, and it just or an observable wrapping a WebSocket, and all of a sudden it just works. So it's because you can kind of put, when you're programming declaratively, you can put things together kind of like Lego bricks and take them apart and put them back together very, very easily. Or if you're dealing with things imperatively, which is how most of us program most of the time. In fact, RxJS is written with imperative code inside. I mean, that's kind of how JavaScript is made. The issue with imperative code is you end up having to manage state all over, where you're setting, you have these side effects from your functions that are setting values and variables that exist outside of your function, so another function later on can check it. And that stuff becomes harder to test and harder to maintain in the long run. And it's easier to end up having weird little bugs in there because of your state management and imperative code.
Now, the example of the drag and drop was fairly simple to explain, and when you're observing a mouse moving around a page, you don't expect there to be hiccups between the mouse movement detection and the object that is observing the mouse movement. What about when you have an observable that is observing something that's happening over a network connection, like something that might be more intermittent, and that might have errors? Could you talk more about how observables handle errors, or how we write our observables to handle erroneous streams of data?
Sure. So Observable has a catch operator, just like Promise would. If anyone that's listening to this is familiar with Promise, there's a very simple operator called catch, and it gives you the error, and you're expected to return a new observable that you will run at the point that you've caught an error. Now, the thing about observables is that they provide some guarantees around observation, in that if an error occurs, you can no longer next error or complete, or if completion occurs, you can no longer next after it's complete, and so on. So what happens when an error arrives on an observable, even if it's an interval that's ticking along, is that observable itself is done. Like it no longer can push out values again, especially after you catch it. It's just going to kind of be replaced with another observable. So error handling, sometimes you really do want it to just die. Like if it's an AJAX request and it hits an error, you just want it to go ahead and let that AJAX request die, and maybe handle the error with a catch and provide some nicer message or something. But in the case of, say, you have an observable or an interval that was doing like long polling or something, it's over and over, it's hitting the same AJAX request. In that case, when your AJAX request dies, you don't want to kill the outer interval. So what you can do is you can kind of isolate your inner chains those chains of observers that you're chaining together by mapping it with using something like a switch map or a merge map to create a second observable that goes and does that work, and you kind of shield your main observable chain that has the interval with a catch inside of there. It's kind of hard to discuss verbally. It's one of those things that a code example helps better with. But basically, the idea is that you merge in another observable to your outer observable chain that has a catch at the end of it, because the observable chain is going to die that has the error on it, period. So if you can isolate that to a separate observable, you'll keep your outer chain alive.
As an engineer, I'm focused on the functionality of my application. Can users upload cat photos to my app? Can users see each other's cat photos that are being uploaded? I am more focused on building new features than things like security or error-free code. And now I don't have to choose between new features and things like security. Codescope JAX helps JavaScript developers secure their source code as they build applications. JAX analyzes your GitHub repository as you are building an application, and it finds areas of your code that can be improved, whether that is a security issue or some kind of error. Go to codescope.com/sedaily today to get free usage of Codescope JAX. That's CODISCOPE.com/sedaily. You can get free usage of JAX on an unlimited number of repositories. My JavaScript applications are usually throwing off all kinds of errors that I keep telling myself I will fix, but I never get around to fixing them. There are frameworks and tools that are changing so quickly. I don't know what security risks I might be ignoring in my application. At codescope.com/sedaily, you can try out Codescope JAX, and it will teach you to write better JavaScript. Thanks to Codescope for being a new sponsor of Software Engineering Daily. Now, speaking from a more general perspective, you talk about if you want to compose functions together, if you want to compose streams together, you talk about working your way backwards in order to think about how you build programming constructs around these observables. Can you explain what you mean by that in more detail? When I saw this talk that you gave, I thought this was a really, really interesting way of thinking about how you compose something together.
Sure. So there's a couple sides to it. Really is you have to look at the end result that you want and kind of figure out what your dependencies are for that particular result. So Draganddrop is one where I talk about that because, at the end you want like the drop, and the drop occurs in a mouse up. There's some dragging in there, and that occurs in mouse movements. And then you don't get the mouse up without the mouse down, so you have mouse down events. So you kind of identify these three sources of event streams, and then you build off of that. So like the actual drag and drop part that's before it starts is going to be mouse movements taken till mouse up. So you build that part, and then you need something to start that, which is switch mapping off of your mouse downs on the target. So that's kind of a way to thinking backwards. Another thing you can do is you can actually go and really look at any line of code. And one thing I'd like people to realize is when they look at any line of code and you look at a variable that's being set somewhere in your code, if you really think about it, that line of code is called every so often over time. Like you could, if you set if you made a logging point there and you ran your app and you looked in console, you wouldn't just see, maybe you would just see one time where it got hit, but odds are you'd see that log out multiple times, depending on where you put this in your line of code. And like, if you think about it, those are values over time, and values over time can be observables. So basically any variable in your app can be represented by an observable. And then you have to think about, well, where did this variable come from? And it's going to probably come from the combination of other, like operations applied to other variables. So then you have to get those other variables and as observables, and then apply those operations to those other variables and then compose them together in order to make your end variable. And this is kind of how you build those things up. Is you you can look at any imperative code and you can actually write it as an observable. Now, the flip side to this, this is what you do when you want to make a section of code reactive. But the flip side of this is I would caution people not to get too excited and make their apps into giant observables. You can, because they embody the setup and the teardown of anything in any number of values, including no values, over any amount of time, which could be infinite or instantly. So you could write a whole app that was just a big observable and have all your variables inside of it be observables. But that's not really what JavaScript's made for. It's not even really what RxJS is made for.
It's not going to be very legible.
Right. Yeah, I mean, it'll be cool. Don't get me wrong. It'd be amazing. It'd be a lot of fun, I suppose. But it's probably not necessary.
Yeah, and I want to get into talking about Netflix and why reactive programming is useful for a company like Netflix. But like when you bring on new people, is there enough of a population of people who are fluent in reactive programming where you can reliably expect a new front-end engineer to understand what is going on with this stuff, or does it take some time to onboard? Or because this seems like one reason why not to build one giant observable is like then you just get into the depths of this being a domain-specific language, and somebody comes on, they're like, this doesn't look like anything I've ever seen before.
Right. So yeah, there's not so much Rx in Netflix that I would say that most people would have a problem with it. However, we do have internal classes and courses and stuff that we run for people that want to take part in them as they're newly hired in. Generally Rx at Netflix only gets used in places where it's necessary or it makes sense. However, on the server end and the back end, we do use a lot of Rx for doing things like highly scalable real-time processing engines and things like that. Mantis, which I think there's been released articles about, comes to mind. But basically, the being able to build things declaratively at scale is important at Netflix. And then, of course, being able to compose these really complicated behaviors and stuff like you would see in what they call Lolamo at Netflix, which is the list of movies, the famous Netflix UI that everyone knows and loves, where they can swipe around in their left and right and up and down in this grid of movies. That's a virtualized list of virtualized lists. And you can imagine that is actually fairly intensive as far as all of the asynchrony that's going on in there. So
sure, yeah. So you mentioned Mantis, by the way. So I think that's the stream processing framework. Is that written in Node?
No, that actually is that's all Java and RxJava.
Oh, RxJava, okay.
Yeah. Which is, a lot of RxJava has been developed in house here at Netflix as well. However, I've pressed them to get some more Node in there. We have a lot of JavaScript developers at Netflix, so I think that's probably a common ask. It's just a matter of the scale and the cost, I think. But I'm speaking offhand because I don't really know all of the reasons why it's Java and not Node. But
probably I would want to say it's like more performant, right? Like I don't know if it matters, but it seems like Netflix probably has more experience running JVM stuff at scale.
Yeah, certainly, and the Netflix is second to none at doing JVM stuff at scale. Like the edge engineering area is where I started at Netflix, actually, doing data viz stuff for them. And it's definitely, when it comes to like the cloud side of the business, a lot of that has been developed in Java. So that's kind of where the expertise lies as far as like how we can push a lot of performance out of what we're doing.
In the Node stuff, is that more for middleware type of things?
I don't really know I don't really know how I can comment on that. I know that
Okay.
I can say that Node does get used a lot by the UI teams, I think, to interface with some of our APIs. But
Right. Yeah, I did a show with Yunong Shao a while ago, and that's from what I recall it was effective at kind of shuttling data between
correct.
the
Yeah,
UI.
Yunong's on my team. I'm the UI platform team here at Netflix.
Oh, okay.
So yeah, that's basically what we use a lot of Node for. Is to kind of not necessarily proxy between those Java layers and the UI layers, but to do some some intermediary processing between those layers.
Right, because it becomes less clear, like, what is the front end, what is the back end? You have all this stuff in between.
Yeah. Well, you're telling me, like, I work on RxJS, right, which is like it gets used in both Node and on the front end, but at the very best, you could say it's the back end of the front end, right? Like,
yeah.
Like it's like I'm not really touching DOM with anything, but people use it to touch DOM or not. So,
right. So, you have a web application like a Netflix or that, like the Lolomo, the list of movies that two-dimensional, basically list of lists. So, do you start to get performance penalties when you create lots of observables on that kind of super complex UI?
You can. I know that when it comes to curating user experience and that sort of thing, especially given that we develop things for extremely resource constrained devices on TVs and whatever, like these things that have like a 600 megahertz processor and like some ridiculously low amount of cache. Like it, in those cases, sometimes they're forced to remove abstraction and kind of raw, JavaScript, imperative code, mutating state sort of things just to try to push performance out of things. But generally speaking, there aren't huge penalties. However, one of the reasons that RxJS 5 was developed, which is the version that I'm working on, was for performance improvement reasons, because RxJS 5 is on average like 5 to 20 times faster, depending on what operation you're doing, than previous versions of Rx. And there's plans I'm actually literally working on right now before I came to talk to you to make it even faster. So it is a concern, and it's something that we're working on, and we either work around it or we work with it. Usually, for the most part, we work with it.
Well, and so there's also this potential to have a memory leak when you don't unsubscribe from an observable. Is this type of thing? Is this hard to profile or hard to catch, like the memory leaks you could potentially get from observables, or does it become pretty easy to reason about?
It's it's no more or less hard to catch than adding an event listener and not remembering to remove it. So I wouldn't say, like, the nice thing is there are ways that you can compose your unsubscriptions to make it less likely that you'll shoot yourself in the foot that way. That being using things like take until or other more declarative ways of managing your subscriptions. But there's certainly a risk. Anytime you're setting up any kind of async thing, there's a risk that you're not going to remember to tear it down, whether it's a WebSocket or a click event, especially if you're doing a thing where you're setting up an async thing based off of some other async thing, like say every time you click a button, you're creating a new WebSocket. Even if you're not using Rx for that, it'd be really easy to accidentally create too many WebSockets or something, right? Like it's be an easy error to make in code. And in RxJS, that would be the matter of, oops, I'm using a merge map and not a switch map, where in imperative code, it's like, oops, I forgot to keep track of my WebSocket so I can close it when I go to open the new one, kind of thing. It's those sorts of foot bazookas are laying all over the place in software development anyway.
Yeah, and so you mentioned React, the JavaScript framework that is becoming so popular. I was looking at going to a React meetup tonight. I've done a bunch of shows about React, and the React meetup in San Francisco is like overbooked and has like 100 people on the waiting list. Like you can't even get in. It's like React is really getting popular.
Yeah.
So how does RxJS interact with a JavaScript framework like React?
Well, I mean, React's just a rendering layer, so you can use RxJS however you want. Like RxJS is just an async library, and React's just a rendering layer. RxJS works with Ember, Angular, React. I've literally used it in all of those frameworks. The way that you generally use it, the way that you interact with React, the way that we use it here, anyways, on a few of the apps that I've worked on, is to use we use like Redux and a Redux middleware. So I actually gave a talk about this at React Rally, but there's a Redux middleware called Redux Observable, and basically it allows you to compose, use observables to compose your more advanced async stuff, but then still use Redux for the synchronous dispatching and state updates and that sort of thing. So other attempts I've seen at using RxJS is without Redux. It basically you use RxJS as though it's Redux. So you use like a scan operator is basically the same thing as the Redux store. And then you subscribe to the outcome of that and update your state and so on. So it's definitely something you can use. The only thing is in whatever framework you're using, if it's in React and you're not using it as the middleware and you're just using it raw, what you want to do is have your on component did mount or your component did mount function do your subscription, and on your component will unmount function have your unsubscribe in there. Similarly in Angular 2, it's what ng on init and ng on destroy and so on. So but you can use it with anybody's framework or nobody's framework if you choose. It's not it's totally agnostic of any of that.
And the other another piece of front-end technology I've done a show or two on is Falkor, which is this thing that's kind of like GraphQL. It's like a way of data fetching. This seems like it's probably not closely related to RxJS, but I figured I'd ask, are there any significant benefits that you're getting out of using Falkor in conjunction with RxJS?
Well, the client side of Falkor doesn't use RxJS anymore because it's the client side of it is meant to be extremely low level. So, I mean, just as low level as Rx. So if it would be like if I wrote Rx on top of somebody else's promise library or something, it would slow it down quite a bit. However, on the router side of Falkor, which is the side that exists on the node end or then on the server, we are using RxJS there, and the advantage there is it just makes it a little bit easier to declaratively pivot some of that routing code, which is of course very event driven because of what it's doing on the server side.
Right. So that is the routing layer. That's you receive some kind of data request from a front end, perhaps, and it federates the request to all the different database services, and then you want some reactive programming in that federation layer to be able to respond to, I didn't have this piece of data in this Cassandra database over here. Let's check this other database, perhaps.
Right. Or perhaps it already exists in some sort of cache or whatever. But
right.
Yeah, that's the advantage that to RxJS there. So actually, it's funny. I just started on the UI platform team, and UI platform is the team that works on Falkor. And I actually haven't worked with Falkor on any of my projects because most of my projects were real-time streaming data type projects. But I've got an item on the docket to go through and update Falkor to RxJS 5, which is what I'm just got the RC1 out of, and obviously what I've been working on for a while. So.
Yeah. So, one description for RxJS that is given on GitHub is RxJS is observables plus operators plus schedulers. Now we have some more context. We've gone through some examples. We've talked about this. Can you explain that definition?
Sure. So observables are obviously the type I've been talking about, which represent they're basically there's two things you call an observable. They're representative of a set of values over time at a high level. They're just a function, and they're also kind of a template for setting up a chain of observation when you subscribe to them. The operators are nothing more than a way to build observables from other observables. So basically a way to take one template for setting up observation and add an additional step to it and return a new template for setting up observation. So you can map and filter and these sorts of things. These are just methods on observable. That's all an operator is. And then schedulers are something that gets used. And a lot of people don't ever need to touch schedulers, honestly, but schedulers are something that you use in order to, for a variety of reasons. One, you use schedulers to handle all of or kind of abstract away things that are going to happen asynchronously, like say a timer or an interval or something like that. You also use schedulers to ensure kind of the fidelity of the events that are being fired by your observable. So, for example, if you were going to have an observable range, and a range from an observable comes out synchronously. But you could do 0 to positive infinity if you wanted. And if you were to do that, and you were to do that in a way that wasn't scheduled, you wouldn't be able to interleave any other operations. It would just lock your browser up while it was doing whatever it was doing, right? But if you do it with scheduling, then you would be able to interleave side effects that were also scheduled to make sure that you weren't just locking your browser up. Like you could do it on request animation frame, which is actually a strategy for animation with RxJS, using a range of 0 to positive infinity and then scheduling it on request animation frame. The other thing you can do with schedulers, you could write a custom scheduler that, say, did something like made sure the Angular 1 digest loop was fired after every event ticked through. It's just a way to kind of control when things are nexted or when you subscribe to things.
Yeah, it's interesting. We've done some shows recently about scheduling at different layers of the stack, whether it's there's a show recently with Adrian Cockcroft, which is a real treat. Obviously, former Netflix employee, but he was talking about his experience with schedulers at the load balancer level and at the processor level, and then at the compute cluster level. When he was helping moving Netflix into the cloud with AWS, and it's funny because in school, I remember in operating systems class, the professor was like, you gotta understand scheduling algorithms. These things are really important. And at the time I was like, I don't see these anywhere else. I see them in academic operating systems. I don't see them anywhere else. And now I just see them everywhere.
Yeah. So they do get used for a variety of things. Like, for example, promises are scheduled technically, but they're always scheduled on like a microtask. Or, if you were going to recursively crawl a tree that synchronously that was like a near infinite tree, like say you had a tree that was 200 nodes deep or something, and you wanted to use recursion to crawl that tree, and maybe you're calling a whole bunch of other functions while you're doing that. So it would be really easy to blow the stack while you're doing that and get a stack overflow. If you use a very simple what's called a trampoline scheduler, you can still in the same job, in the same like JavaScript task that's being run, do that without ever hitting a Stack Overflow by using a trampoline scheduler, or what in RxJS 5 is called the queue scheduler. And what that does is you give it you say, oh, schedule this function to run like right now, and it takes that function, stuffs it in an array. Then it says, am I already looping over this array and pulling out functions and executing them? No? Okay, well, go ahead and start doing that. And then it starts looping through the array, shifting values out of the bottom of it, and executing those values because they're all functions. And then if one of those functions happens to schedule something again, guess what? It gets stuffed in the same array. So the next turn around the loop, it's going to pull it out and execute it and so on. So in doing so, you take something where recursion was going to cause you to have a Stack Overflow, and you flatten those stacks. Like you basically knock the stack over every single time you schedule. And that prevents those from happening.
Help me understand. When I think about JavaScript, I hear JavaScript is this single-threaded event loop, but here we're talking about scheduling perhaps different threads. Can you help resolve that misunderstanding?
Oh yeah, sure. Yeah, it's still not on a different thread. So when you schedule, there are a variety of things that can happen. Is one, if you schedule on a microtask like a promise does, or what they call a next tick now, what that's going to do is it's going to put a different event on your event loop. Like the event loop is essentially this high-level JavaScript concept that says, oh, you're executing code, that's an event. And I'm going to execute that code until completion. And then I'm going to move on to the next event in my queue. And it just basically, you just take these events and you keep putting them in this queue, and it pulls them off in order and runs through it and then drops it and goes to the next one. It doesn't really care about what the previous one had in it, right? So whenever you have a mouse click handler, it adds an event to the event loop. And then whenever you get a page load event, it adds an event to the event loop. And whenever you get a WebSocket message, it adds an event to the event loop, and it pulls it out and processes all those things in order. And when you're scheduling something, there's two places it can end up scheduling, but it always is in the same thread. There's just one thread that's pulling these things out of a loop and executing them. But when you're scheduling something, generally speaking, you're scheduling it on a different event in the same event loop that one thread is spinning through and eating, with the exception of trampoline scheduling, where you're actually queuing something up inside of an array that you're looping over in the same technical event on the event loop and pulling things out and executing those things. So that's where you get some confusion. But yeah, there's only ever one thread. The best you can do for quote-unquote multi-threaded JavaScript isn't technically multi-threaded. It's more multi-process JavaScript, where you can spin up a worker thread and have it execute things. And it has to communicate with your main thread, it would have to serialize data and communicate from one process to another with another event. So, but yeah, it's basically the idea of an event loop in JavaScript is you have one thread, and that thread is basically saying, hey, do I have an event in my queue? Okay, pull it out and execute it. And then next time I get another event arrive, if I'm not executing anything, execute it now. Otherwise, put it in my queue and I'll get to it later.
So as our time draws to a close, what's coming in the next? What else is coming in the next version of RxJS, RxJS 5? You've talked about it a bit, and I mean, what else is exciting to you in the front end world right now?
Oh, there's tons of exciting stuff to me in the front end world. In RxJS, right now, we're shoring up the version 5. We got a release candidate out. It's which basically means that it's stable, but there might be some changes that we have to make that could be breaking, but for the most part, the API is all stable. And so getting RxJS 5 out, stable production release, and then there are some really, really cool performance improvements that we're looking at for doing for version 6, which won't break most of the, 99% of the public API won't break. It's just that we're not coveting that major release anymore, which a lot of open source projects are no longer doing. And in version 6, it'll be some massive performance improvements, and then some improvements for using for error handling in Node. So what you'll be able to do, ideally in the next version, would be to actually take out any kind of error catching for Node use cases, because a lot of Node developers don't want any try catching automatically happening in their asynchronous types like they do with promises, because what that ends up doing is giving them less visibility into what happened at the point of a crash on a Node process. What you really want is, oh, there's an unhandled error. Don't try catch it at all. Just let the process die, like panic and die. And then you get a core dump so you can look and see exactly what was in memory, exactly what line of code you're on, and so on. And as soon as you wrap anything in a try catch, you lose that visibility. So we've kind of cooked up a way to have that sort of behavior as an opt-in for RxJS. So that'll make it a little bit better or nicer for our node processes here at Netflix.
So, excitements on the front-end world more generally?
More generally, I'm excited just in general. All of these frameworks are coming together. I think React has gotten a lot more stable. Ember's, fully made its switch to 2.0 and they're doing good things. And then Angular 2 has just been released, and I'm particularly excited about some of the stuff that they're doing with, they've got a CLI tool, and you can do basically build time compilation of your templates, and they don't ship any template compiling stuff to your client anymore, which drastically reduces the size of what you have to execute to run an Angular app. And it also basically means that an Angular app, an Angular template is going to run as fast as it possibly can, where, with React, although I love React and I love JSX, you still have that layer of indirection where it's going to have to diff to virtual DOM trees to make decisions about how to update the DOM. With Angular, it'll just basically call a function that updates the DOM. So like the performance side of that is really exciting to me. I love Redux. I like seeing how Redux has taken shape, and Redux Observable has made a lot of my apps really great. I'm particularly excited about those areas.
Yeah, well, certainly the winner in the Angular versus React perhaps competition is the end user of these
absolutely.
apps. I mean, you get great performance out of our UIs these days.
And developer ergonomics is getting better and better. I think it still might suffer a little bit in Angular 2 because Angular 2 is so new, but I know that's something that those guys are working on. And then developer ergonomics around React, because it's so simple, it's fun. Frankly, it's fun to use React with JSX and that sort of thing. I get a kick out of just using JavaScript to build out markup. It's pretty cool.
Definitely. All right, Ben. Well, appreciate you coming on the show. You Netflix folks are always thought leaders, and it's so great to have the chance to talk to you. So thank you. Appreciate it.
Yeah, awesome. Thanks for having me.
Thanks to Symphono for sponsoring Software Engineering Daily. Symphono is a custom engineering shop where senior engineers tackle big tech challenges while learning from each other. Check it out at symphono.com/sedaily. That's symphono.com/sedaily. Thanks again, Symphono.
Wow.